So I'm here today to talk about artificial intelligence and robotics, which is what this talk is about. So I hope that as far as you know more or less from robotics, I hope that by the end of this talk, at least you get the key concepts that are going to be trending in the following years, which is the aim of this talk. A little bit of history, but also a little bit of what is coming next, okay? So let's start. So the talk is called What If Robots Needed Our Help? And this comes because when I was, so I'm a PhD student, I have, well, after thanking the sponsors, of course, I have these slides to present myself, and I am currently doing a PhD, and my PhD is about multi-agent planning, but basically the first application or more direct application of multi-agent planning is robotics. So I had the opportunity to go to Carnegie Mellon University 2 years ago, and I met there a lot of roboticists. Especially I was working with a woman that inspired me a lot. And basically she told me what was important in her life to change the way robotics have seen before and after she had that idea, okay? So that was basically what gave me like a strength or power to put this talk right after I came back to Spain, because I think that it's very important to everyone to know not only, you know, these super robots or this concept of robots ending humanity, or, you know, this artificial intelligence like Terminator that it's going to end with all of us, but instead to know all these people that are creating something useful and better for us, for human. So that's basically the idea, and that's everything that I have to say to introduce this talk. About myself, as Veronica was saying, I'm the organizer and founder of TechFest. If you have heard about the conference, it took place a week ago in Madrid. And if you haven't heard, I hope that you follow us on Twitter right after this talk, because we have a lot of activities that I'm pretty sure that you want to check online. And we have a lot of recorded talks and everything, so just have it on mind, because it's going to be awesome for you to know. And I'm also Anita Borg scholar. Right now it's recalled Women-Techmaker scholars. And I went to the Grace Hopper. For those women who are here on this venue, I encourage you to apply to Grace Hopper conference in the United States. If you are a student here in Barcelona or Madrid or anywhere, you can apply and you can get a travel grant completely free to go to the States and to this conference. And believe it or not, this conference has like 15,000 women coming from all around the world. So it's really, really crazy and a really, really activity of empowerment for women. So I encourage you to apply. And let's start with the key points of this talk. So I was saying to you, I'm going to talk about robotics. And basically in here, I hope that you all can see what it's in here, but it's basically what I'm going to talk about. So I'm going to talk about the beginnings of robotics. I'm going to talk about this concept that it's called symbiotic autonomy. And then I'm going to talk about social and service robots, which are two main classification of robots right now, at least the ones that can help us, okay, not destroy us. And then I'm going to talk a little bit brief about self-driving cars, human-robot coexistence, and transparency, which is a key point to go on robotics and to grow up. Okay. So let's say it's March, 2018. We have heard about a lot of robots. We have the social robots, the service robots, the industrial robots, which were the first ones. And then we have self-driving cars from different companies, right? So everyone has heard about DeepMind, for example, or these Atlas from Boston Dynamics, right? Or all these robots that have been created by Boston Dynamics, and the Falcon 9, right, from SpaceX. So everything looks really promising, right? Like it's like the future is right in here. Like we are really close to this imagined world that we have in our minds thanks to science fiction, for example. And basically what our present looks like, it's sort of like this. So we have the winner here of DeepMind that won the championship of Go, which is like a Japanese chess, kind of. And it was won, of course, with artificial intelligence, deep learning, concretely. We have also these assistants, right? These voice assistants, like the Google Now, Siri, Cortana, Alexa, okay, we have a lot of them right now. We have some robots, like this Asimo from Honda. And we have also self-driving cars. So this is what I was saying. It looks very, very promising. But then Boston Dynamics came up and released this thing. So what happens is that they managed to make a robot do this backflip after a lot of training, and everyone, it's like, oh my gosh, like this is going to be the end of humanity, you know? Like, so they have two videos, one about this and another one that it's about two robots trying to opening a closed door that looks a lot like this Jurassic Park scene of the velociraptors, right? That they try to open the door and they're like, oh my gosh, we're going to die in here. So yeah, so this looks pretty cool and pretty scary at the same time. But basically, the first thing that I want to say here is that really this is not our real world. Like, the real world of the people that works in robotics looks a lot like this every day. Like, everyone is like trying a lot, you know, with this trial and error all the time. And you see a lot of more this than the other thing that you record in a demo, right? Which means that it takes a lot of effort to just achieve this movement, okay, this backflip that the robot was doing. And the same thing happens if we talk about some other environment, like this one with football, and this other one that is way easier, but it's also very dangerous, which says like, Siri, I'm bleeding, so I need your help, right? Can you call me an ambulance? And instead of understanding, you know, like, call me a real ambulance, Siri is understanding, hey, I will call you an ambulance from now on, you know, like this is going to be your name. Which, you know, it's something that we need to take conscious, you know, about. We as developers or researchers, it's really important to have this in mind. So the first part of this story starts in 1997. Believe it or not, there were already people working on robotics especially, but in all these things about artificial intelligence. And what happens is that in 1997, we have this clumsy and heavy robot. We have also some AI competitions going on, a little bit simple, but they were there. And we have also languages like Lisp, which were almost basically based on functional programming, which is now getting like more and more people to work on again. And what happens here? So I want you all to look at this picture. So, especially to this woman. So basically, this was the woman that I was working with in Carnegie Mellon, and her name is Manuela. And she was one of the first people or researchers that changed the way we see robotics right now. And the first thing that I was told when I was there was like, hey, you know, like Manuela is the boss here. Like in the university, she controls everything. And it was like, wow, like a woman controlling everything on robotics, like this computer science field that it's like really, really strong and, you know, and has really relevance. So yeah, actually she was controlling a lot of things in the good way, I'm saying. And in 1994, she went to the States, so she was finishing her PhD in Portugal, and she got a job there in Pittsburgh, in Carnegie Mellon. And she starts to you know, like be a PhD advisor, which means that you need to have students, these two concretely, to promote them to win this, to earn this PhD, right? So they were all at a conference and they were thinking about the PhD topics of these students. Like she wanted to do it about robotics, but they weren't sure about which part of robotics they should do it. And after being at this conference, they decided to say, okay, so if we want to, be better on robotics, we need something where we can test our environment against some other environment that looks like the same, and so that we can compete and make each other better with the time, right, and the effort. So what she founded was the Robocup. So basically, the Robocup is something that now it's very, very famous, especially in robotics, but also outside of robotics. So it's a robotics league of football. And what she did 20 years ago was to define everything that was going to take importance in this league, okay? So they started with something very, very small that right now, after 20 years, is something really, really big, and that it's like the main benchmark of robotics right now in order to test your robots and to get better in research, okay? So basically, you can imagine in 1997, it was very difficult to just put together a lot of research groups from all around the world. Just think that even an email, you know, it's not like right now that you can write a WhatsApp or something. So it took a lot of effort for her to convince other colleagues to just listen to her and to believe in her idea. So the first competition took part in these years that you have here, and it was very simple. So basically they had a team of 5 robots that you can see, well, 5, 6, you can see it here. And the idea was to achieve that this team of robots were able to strike a goal, okay? That was the main idea. There was no artificial vision, there was no roles, there was nothing, but just trying to put them together to play and see what happens. And in order to replicate this environment, because this was in her lab in the United States, just to think, what about this environment in Europe or in Japan, okay? So basically, she had this idea of doing everything easier for everyone and simple. So she said, okay, I know that it's hard, but maybe we can just take some common things that we are used to so that everyone can buy usual things and just replicate what we are doing here. So she decided to establish the same measures as a ping pong table for this field, for the football field, of course of green color. And then they had all of them, mandatory was 5 robots, these small ones that were built from scratch. And then the ball that they were going to use was going to be of a golf-size ball, okay? So everyone had the same measures without, you know, like being very expensive or like specifically built for this environment. And they had 2 leagues. So they had this small-size league and the middle-size big league. So the bigger the size, it's more complicated as it takes more time for the robots to move, okay? So just have these things in mind. And what happened? So the thing that happened is that they were going to compete in a conference in Japan. There were 5 teams from all around the world. It was very small, but still growing. And what happened is that Manuela won the competition with her team against France. And basically, you can imagine in 1997, if you can see the headlines of a newspaper saying, hey, robots are winning, you know, like football competitions, it's something that sells very quickly. So basically what happens is that she appeared in all the front lines of the newspapers, especially of France. And what she told me was that there's something that it's additional to your work. So I knew that my idea was good, but in order for your idea to work, apart from passion, you need also time and also a little bit of luck. So this happened in this date here. But what she told me is that if this would have happened the next day, she would have never had that repercussion because it was the day that lady died. So, you know, like she would never get the front line for this research project. So that's why after that, after appearing in all these newspapers, she was able to obtain all this funding and all this trust from other people around the world to work on Robocup and to success like she was doing, right? So she's been working on Robocup for the following 20 years until now. And right now, as I was saying, Robocup is huge. They have a standard league which is a league where you can just buy the robot and just program the robots. You don't have to build them from scratch. They have also a league focused on in-home activities, so not football. They have also a league about rescue tasks. So, like this has grown crazy. But the thing that why it worked with football was, again, because it was something simple and something that everyone knew around the world. So football, it's a massive game and has a lot of interest around the world. So besides that, there were a lot of tasks that were important for robotics, because inside football, you have multi-agent coordination. You have also artificial vision if you want to check where the ball is or where the robot should be head off next. And then you have, of course, movement, and you have roles. You need to know which robot is going to take the role of the forward and which is going to be backwards, or on the middle side of the field. So this is what makes robotics funnier and more interesting to some other people. And then, continuing with CMU, with Carnegie Mellon, in 2005, there was some other, highlight, after this Robocup. This wasn't about Manuela, but was about people working with her. So basically, the Defense Ministry of the United States decides, which is called DARPA, which decides to release a challenge to everyone on research groups from the United States, which is, we need to improve on self-driving cars. So what we are going to do is kind of the same thing with Robocup, but with, a lot of money. So they released a prize which was $1 million to the team that achieved with a self-driving car to drive almost 12 kilometers in a desert. Okay? So this was 2005. Right now we have a lot of self-driving cars, testing right now on the streets, but what I want you to think is it was already 2005 when they were talking about self-driving cars. So we have here two guys. This one is from Stanford, this one is from CMU, from Carnegie Mellon, and Sebastian Thrun, which is the guy from Stanford, won the competition with his team. But he won, not because he was better, it was because the team from CMU got stuck in the last 100 meters of the competition. And what they realized is that, of course, it's really difficult to test your things, right? Even in real environment, but it's also more and more difficult to test when you don't know where it's going to take the competition. So you have to have a lot of things in mind, but you don't know what will happen until you go there and you try to run your thing, right? So this started a new thing, which was to compete against universities, to get better and to have, the best students and all this. But the good thing was that starting from this point, Sebastian Thrun, instead of getting all the knowledge, he decided to create all these MOOCs that you have heard about, all these online courses that you can just join in and enjoy yourself and send all the deliveries and tasks and, to have all your exercises marked. So he was the founder of Udacity, and he did that 2 years after she released some course on artificial intelligence for everyone. So this was, again, a key for everyone to get attracted to the self-driving cars community. And he did a lot on that for free. And it's something, that it's really, really important for us in robotics. And then we have this guy, which is Mark Revert. He is also a CMU alumni of the same university I was talking about, and he is the CEO of Boston Dynamics. So if you are really fan of robotics, I'm sure that you have heard about this company. And it was the one of the backflip that you have seen before, okay? So this guy, I got the chance of attend one of his talks when I was there, and what he said was something similar, not in the same sense as Manuela, but he was saying something very important, which is trust in your idea. So he was there at the university, he was doing the PhD, and he was obsessed with this thing, with stability on robotics. So what he was saying was like, I want to do my PhD about how to make a robot stand on just one leg. He didn't know why, but he wanted to do that thing, and he had passion for that. So his advisor told him, like, you are crazy, you are never going to, do that. But that served to him to just do research about how he could accomplish that, and he found inspiration on animals. So if you focus on the videos of Boston Dynamics, which you can see some of the robots here, most of them, or the 90% of them, are inspired into animals and how they behave and how they move. So basically what this guy has been doing since 1992 has been to just replicate, or almost replicate, the movements of different animals into his robots. And he has done a lot of research again on stability and how to stand in 4 legs or 6 legs or different number of legs. Also on these 2 legs as the Atlas. But like the importance is to know your passion and to say, okay, I'm going to do this thing, and trying to find inspiration in something that you see in your everyday. And then comes back Manuela. So what Manuela told me was, okay, I was there, I was seeing all these improvements on robotics, but we had the same issue as we had in 1997, which was we have robots, but no one is using them. So there's still a lot of work for the robots to get to the real world, right, to our everyday lives. So basically what she was thinking was, okay, it's September, almost, 2011. It was a little bit earlier, but more or less this time. So she decided to say, I'm going to create a project from scratch that, again, is going to have the same kind of ideas as the Robocup. So I'm going to create some robots that are easier to build. Why? Because it's cheaper. So a lot of people in research had a lot of trouble to get funding to build their robots or to have robots. So she decided that she was going to do a project with all her students, creating all these things that you can see here from scratch. And the idea behind that was to force these robots to collaborate with humans. So that's why they are called cobots. So cobots comes from collaborative robot, and this is what the main talk is about. So the idea of the cobots is very simple. As I was saying, is collaboration, human-robot. But the amazing part of this is that you can see that the robots are really simple. Okay, they are also like ugly or not so cute, but they are simple. So they have these wheels here that can turn them like 360 degrees around without much effort. They have some sensors here to know where you are, touching something. They have also these basket cases, and they have this iron thing like a skeleton. All of them are the same. They have also a Kinect to know how far or how close they are from someone or something. And they have also a tablet, okay, and a camera. So as you can see, this is something that you can easily build even at home, okay? You only need this platform that might be like the most difficult thing. So what happens with cobots is that without realizing, she was working on something that later she called symbiotic autonomy. So robots are aware of their perceptual, physical, and reasoning limitations and proactively ask for help to humans. And this might be silly, but no one was doing this thing. So everyone was thinking, I'm going to do the perfect robot, or I'm going to do the perfect robot for this task. And what she was doing was the opposite. So what if my robot is not perfect, but I can force him to collaborate with the humans next to him, and to ask for help. And if the human is able to answer, then my robot is going to be able to solve that task for me. So that was basically the idea, and that's why the cobots didn't have arms. So if you have realized in this picture, one of the things that you can suddenly see is that they do not have arms, so they cannot pick anything. And that was one of the key points to force collaboration, or at least collaboration that was easier for humans. So in order to prove or to test this project, after she had all these cobots built, she decided that as she had many visitors, because she was famous, So she was going to release her cobots, and the cobots were going to receive all their visitors, and were going to, get to the visitor to her office there in the building. So the cobot knew where he was placed in the building. So it was a building of 7 floors. So I remember that the cafeteria was like in the 3rd floor or something, which was always where the cobot was waiting in case someone was coming. And what happened is that the cobot knew where he was because of Wi-Fi localization, and knew about what was around because of these Kinect sensors, And when the cobot was driving someone towards the office of Manuela, the funny thing was that at some point they knew that they needed to use the elevator. So something as simple as using the elevator is really hard for robots because, first thing, they don't know what is an elevator, right? They know that, because they had the knowledge, they know that they needed that in order to go up, but there were a lot of things that they didn't know. So what they started to build indirectly was a lot of human-robot interaction, but also knowledge. So what happens was that something as easier as getting into the elevator was giving information to the robot about, hey, can I do this thing? I can't, or I need help, or I don't anymore, because now I know where the elevator is, or I know which is the best elevator for me, okay? They had different elevators with different sizes as well. So basically when they push the button of the elevator, which of course some human was doing it for the robot was saying, okay, so let me know when the elevator opens, and then I can get in, and then let me know when the elevator opens again so that I can get out. And the best thing is that all the people were really into it, because it's like, wow, like a robot is saying to me, hey, I need your help, so help me, please. And everyone was getting a lot of attention on this project. So they started doing this thing on elevators, but they then also thought, okay, so if we have these cases on the robot, I can ask the robot to bring me some water, for example, or coffee, because they had a lot of kitchens around the building. So it was easier to say to the robot, hey, can you get me some coffee? And they know that they had to come back to the same office. But the thing is that the robot didn't know what coffee was about. But they knew that if something was not known, they could ask. So they formulate this easy question, like, what's coffee, to the next human that was there, right? So, or where is the coffee, which was, of course, more useful. So where's the coffee was like, hey, coffee is in the kitchen. So the robot was going to the kitchen. And then after doing all these things repeatedly, then the robot infers, hey, I know that the coffee is on the kitchen. So they got faster and faster in these kind of repetitive tasks. And I have here a video, but I will leave it at the end, because I don't want you to get really, really into this. I want to make it a surprise. But it's really, really impressive how everything works related with cobots, because they are very simple, but they do a lot of tasks. And of course, they got into the media, they got into the newspaper. It was like the next big thing on robotics. And the good thing is that thanks to this project and some others that were running at the same time, we have now social robots. One of them are very famous from this company that it's right now called Softbank Robotics. So I'm pretty sure that you have heard about these kind of social robots like now Pepper or Romeo. So they are very famous. They come from France, even though they are now building them in China. But basically, they were helping a lot of kids, specifically in some sort of diseases, or into people that have little capacity for move, for example, or that, in hospitals, basically. Because the thing with social robots, as cobots were helping, the thing with social robots, when they have these nice, interfaces, the thing is that the kids see them as friends, and it's way easier to communicate with a robot, even though you can't believe it at first, but it's way easier for kids to communicate with these kind of robots than with a human or a medical center or whatever they are. So it was really, really nice to see how these robots were getting at least into hospitals or into these social projects to help people around. And then we have the service robots, which are more close to closer to the cobots, which basically what they do is to solve tasks, especially the ones that are repetitive. And I have put here 2 examples. This one of PAL Robotics, because they are here in Barcelona. So if you are interested in robotics, maybe you can, just say hi to him or to them. And this robot is especially running in airports, not in here, but in Dubai. I know that they have a lot of them, and in some other airports of the Middle East. And then we have Baxter, which at first, if you see Baxter, it's like a little bit weird, but it reminds you to these industrial robots. So the magic about Baxter is that was the first robot to be built for industrial things, but with materials that are easier to manage for humans. So the problem with these industrial robots was that they were really hard to manage with a human next to him because of these hard materials like iron. But Baxter is made of plastic, and it has a lot of sensors all the way here. So it was the first robot that allowed research groups to have them inside the labs without getting a lot of money to just buy one of them. So it has a tablet as well in case you want to do something about interaction with humans. But basically they are used to tasks that are related with manipulation of objects. So it's nice that you have this version, because otherwise research groups would have everything way difficult to improve in this kind of tasks, which are always very, very helpful. So now, coming right now to the present, where are the robots? So the thing is that right now we know that the perfect robot doesn't exist. We know that if we want robots, we need to do something similar to what Manuela did in CMU. So we need robots 24/7 here with us, and in different places, of course. And they need to learn from humans, but also we need to learn from robots. Something that came up these last years, inspired on the cobots project, was a European project that it's called Strands, and it has been running on the University of Birmingham and some others, I think, on Germany. And if you see this picture, it looks pretty similar to the one of the cobot. But the main difference is that it looks a little bit, well, like nice or nicer. And the idea was to get this robot, instead of into a university, into a professional environment. So it was some kind of consultant and company, and they used the robot for kind of the same things as the cobot. But what happened here is that they learned a lot about security, safety, and vision. Why? Because in order to test the robot in this real environment, of course, they needed some certificates to run everything safe. But they realized that sometimes in these kind of environments, not only you have adults, but also you have kids, because maybe someone brought the kids to the office for something, or to just picking them from school, right? So they realized that they didn't test enough the robot. So what happens if you have a kid and it's like this height, right? And you have tested everything to be here. So the kid is identified as an object. So maybe you have a problem if the robot, tries to push the kid because it looks like an object. So this gave a lot of discussion about this in term about diversity, inclusion, and trying to test for everyone and trying to have these things in mind. And the same happened with the Uber that was tested on Pittsburgh. And the thing is that they were picking up passengers for free, okay? So you could just ask for the Uber, and maybe the self-driving car was coming to you for you to pick up. And what they realized is that they had a lot of issues when the car was going through the bridges. So Pittsburgh has a lot of bridges, and these sensors got a little bit confused because of the colors and the water and the buildings. So sometimes they had to be careful about how to control everything around. And same thing with self-driving cars. I'm going fast on this one. Because even though it can seem it's way complicated, it's on the other way around. So it's easier to just drive a truck, especially in the States, rather than a self-driving car, because usually these trucks are built to go on huge roads, and in the States, the huge roads are mostly straight. So, you just let your self-driving truck going on, and he will, get the point, the goal point. But for the self-driving cars, the problem you have is with urban traffic, for example, or passengers. So some key issues related with all this, and also with robots, are safety, transparency, and continuous learning. So about safety, what I want you to think is like sometimes when we see all these robots or these new artificial intelligent things, we need to think less like humans and more like machines. And I'm not saying that we need to be harder or anything like that. What I'm saying is that sometimes we need to think like out of the box and try to think different designs even. So what they were saying about these self-driving cars when they had trouble detecting something was like, what if we make a car that doesn't look like a car? What if we redefine the concept of cars, for example? Or what if we put the lights somewhere else or some other sensors that we haven't thought, right? And the same thing about being God as a developer. So in this kind of environments, we have a problem when we are the ones that are programming the code, right, or the decisions. So until which is my responsibility, or where my responsibility stops, and where I need to take a decision about whether to take this or this other decision when they are like closely going to fail, like both of them. So in any case, what is really important is that we have this kill switch button that allows us to stop whatever is going on artificial intelligence inside our vehicle or robot or whatever. So the thing is that we need to be not passive when we have these new ideas on mind, or we have these new systems where we can interact. We need to be aware that I cannot get into a car without knowing how to drive. Because just imagine that it's not that you have someone right in front of you and you are going to hit him. Just imagine that suddenly there's a storm, and of course your artificial vision system is not going to be as good as it was when there was sunny or a day like today, right? So we need to be aware of that. We need always this collaboration of human plus the artificial intelligence system. And of course, we need to add expressivity, which is the last concept that I want to introduce today, which is called, in summary, transparency. And what means transparency? So transparency is about understanding what the robot is doing before he tells me what he's going to do. So if you have seen maybe some videos or some demos about robotics, you have realized that at the beginning you don't know what the video is about, even, I mean, if you haven't read, of course, what it's about, right, the abstract. But if you just see the video, sometimes it's really hard to get what the robot is just doing. So basically, expressivity helps us to just go faster on that way. And coming back to cobots, what they did was something very, very easy that turned out to be one of the best ideas they had. So basically, as they had the cobots running for years, what they realized is that people were losing this interest from the beginning because, of course, you get used to it. But at the very end, it's like, okay, so we are realizing that people are not paying attention. So what if we put some blinkers, like the cars have, to know where the robot is going, either right or left? Or what if we put this light here, and suddenly it comes up to be a progress bar, where I know how far is my destination, for example, where I'm reaching Manuela's office. Or this other thing, right, like lights. What if this, instead of being just a progress bar, it's also a red light that blinks whether someone is trying and not allowing me to move forward, right? Because maybe someone didn't realize that you were just behind. And just with this, they were capable of increasing expressivity and interaction with humans way farther than they have done. And of course, continuous learning, as I was saying, full autonomy, this is really, really important. And just to finish, some conclusions. I'm not going to say it, I'm going to give you some homework, because what it's really, really nice is to get more about this thing. I only have here 40 minutes, but I know that probably you are very interested into these topics. So one of these students from Manuela is Astroteller, that is right now, he has came up with this head of Google X. So if you haven't heard of Google X, I hope that you have. But it's this innovation lab from Google that it's in San Francisco in some secret place. So he is now in charge of different projects, but especially one about drones and how the concept of drones can change the concept of ownership. So I encourage you to check this interview, and also, of course, the one from Manuela, where she tells, even better than me, how humanity and AI is going to be something that needs to coexist and that we need to get used to it in the best way that we can. And finally, just a reminder that I'm also involved into this book project that is called Women in Tech Short Stories. So you have the book over there if you want to check all the stories that we have written. They are personal stories about us, and I think that it's very interesting, especially if you're a woman and you want to know how we ended up in technology and to inspire maybe some of you to get into technology. So please read if you have the chance and follow us on Twitter. And yeah, that's all on my side. If I have time, I will put the video.
So thank you very much, Nerea. Somebody has any question for her? Okay. We only would have 3 questions, okay, because we're running out of time.
Thanks for sharing this information. I think it was funny and it's interesting.
Great.
So I have a question about maybe philosophy. What do you think about human being managing relationships with robots?
Human being, you mean?
Yes, I mean feelings and that kind of things.
So there is now, some kind of ideas going on related with this philosophy of how robots are going to replace humans in work, and if the creators or the buyers of those robots have to pay something in compensation for this work that they are going to replace. So I think it's going to change a lot of things, but I think that it's way better to not be scared of it. Of course, it's going to change. I'm pretty sure that it's going to change the way we see work, but it will also come up with some other works. So not only the ones that, of course, are going to control robots, because robots are going to be an important thing in the future, but what I mean is that all the creative stuff is going to get more attention, and it's something that maybe we have forget through these last 50 years, for example, since, I don't know, all the Industrial Revolution and all these things. So I think it's better than just being scared of what is going to happen or the way it's going to be solved. I think it's better to think about alternatives, and it's a thing that a lot of researchers are now working, even with lawyers. And I know that in the United States, they are really worried about this thing. They are starting in the European Union to think about laws that join these two things, like payments, robots, and humans. But we will need to get to it. I mean, if you can say something positive about this, is that we can get rid of repeated tasks, and we can get more focused on creative or personalized tasks, or some tasks that are different, and that can make us more enjoyable our everyday. So just think in that way, either, just in the negative stuff. Thank you. Some other questions?
Anyone else?
Very nice presentation.
Thank you.
I'd like to ask you about how you see the present and future of robotics applied to health.
In health, you mean? Well, health is really a good area to work on robotics. Like, I know that right now they are doing a lot of telepresence with interventions, operations, and the good thing about robotics or any machine is that they are more precise than us. So the same as in the self-driving car, it's way safer to drive inside a self-driving car rather than on your own vehicle, because you have all the knowledge, that has been cached all around the world. I think that health is going to be something that is going to get way better with robotics. Not only robotics, but with AI as well. And one of the companies that are now leading this thing is DeepMind as well in London. They have created some kind of sub-company that is focusing just on health. So that means that there's something going on over there, very interesting. It's secret, of course, but it's there.
Thank you. One last question? One? Okay. Oh, okay.
Hello? Yeah. It's a little bit of a strange question, but what is the future of robotics for robots? More specifically, because lately there's been a big splash in the news about one of the robots becoming a citizen of Dubai, I think, isn't it? And we have to think of them as being, the future is robotic, and so they're going to be a very big part of society. And as you said, children see them more as their friend. So the more that they become developed and more self-aware, they become more in their likeness. What is their future? Do they get rights? How does that work out, really?
No one knows. Actually, I know that there's a lot of conversation going on about which is the place or the legal place of robotics inside, humanity, but no one knows what will happen. The good thing that they know is that when all these robots have been tested in real environments, the reception has been way better than expected. The same way that happened with the self-driving car in Pittsburgh. So Uber thought at the beginning that no one would want to try the self-driving car, and then happened the opposite. So everyone wanted to get inside and having all of these drives with no driver, right? So the same thing with robots. I think it's something that maybe we are more scared because of all the things that they have told us, maybe movies or science fiction. But what we need to think is that at least 99% of the people working on robotics are thinking in some solutions that are ethical and better for humans. So, I'm pretty sure that it's going to be good rather than bad for us. And about rights, I have no idea. I have no idea. I'm an engineer, so. Yep. So as we don't have time, I will also suggest you to check the Cobots project in YouTube. They have a lot of videos, and I'm pretty sure that you will find them interesting. Just think that it's about 2010, and they have reached a lot of things. So just check it out. Thank you.